All right, let's stop at 30. So I'm going from the first quadrant down to the fourth quadrant, okay? So my speed starts out at, say, 2 right here. What does my speed go to right here? It goes to 0. So my speed, it slows down, and then it speeds up, but in the negative direction. That's as if I were to take something and throw it up in the air. It would slow down, 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 stop, and then come back down in the negative direction, speeding up. That's what this is representing. An object that's falling or goes up and then comes back down again. So E is the right answer here. I know why you put A, because it looks like it's decreasing, right? It has that negative slope, and it looks sort of downhill, but it actually decreases and then increases. The speed does, but in the negative direction. Okay? We have some more like this. Let's try them out. If you were listening, you got the answer for this. When I toss a ball straight up in the air, right after it leaves your hand, before you catch it, which of these represents the V versus T graph? When I toss something straight up in the air, and then it leaves my hand, it comes back down. You're in lab, you're going to do this soon. With the basketballs, you might have the basketballs yet in lab? No. Alrighty, let's stop at 45. 45. Okay, good. D is right. That's the one we just saw. So I start out with a big speed. It goes to 0, and then I get bigger in the negative direction. Remember, positive y, negative y. Positive v, negative v. That first and fourth quadrant. Okay, now we're going to do something different. I take a ball, and I drop it, and then it bounces back up to my hand. It's a really bouncy ball. You drop it, it goes to the floor, and then it comes back to your hands. Which of these represents the velocity versus time for that? Think about what the velocity is doing. Is it speeding up or slowing down? And is it positive or negative as time goes along? Now let the numbers here be letters. 1, 2, 3, 4, it's A through D. Is the velocity of your ball positive or negative initially? Think about that. Don't answer right away. But I drop the ball and it goes in that direction. Is that a positive velocity or a negative velocity? And once you answer that, you can get rid of some answers. So like if it's positive, it has to be this one or this one. If it's negative, it has to be this one or this one. It's a really good practice when you're taking multiple choice exams, standardized tests, that sort of thing. Okay, good. A lot of you have made a good choice in moving away from that path, the wrong answer path. Okay, let's stop at 125. 125. Okay, so D is the right answer. I start out with a small negative velocity. Small negative velocity. And then it gets faster. In fact, this is its fastest speed just before it hits the ground. All right, so at this point is where it hits the ground. And what happens to the speed of the ball after it hits the ground? When it starts coming back up, is it positive or negative? Positive. And does it come up with a, right after it hits the ground, does it have a big speed or a small speed? Big speed. That's its fastest too. So I have No speed at all. I drop it, drop it, speeds up until it gets to the ground, and then it bounces, and it goes from a big negative velocity to a big positive velocity. You get this discontinuity in the graph here. And then it slows down until it comes to your hand here. That's taking a ball and dropping it, and it comes back up to your hand. You're going to do this thing in lab with the basketballs, where you drop the ball, and then you create these sorts of graphs. We look through videos and stuff. It's kind of fun, actually. Okay? You're making me a little nervous. Are y'all getting this, sort of, kind of? Well, I know that 30% of you are not. So, stick some more. Oh, that's the last one. All right, we'll come back. We'll address it some more. We'll talk more about graphs, okay? But before we do that, I want to address some of these problems, because I want to work a problem that's very similar to one that you have in your OpenStack homework assignment, which is due, this was due Friday, right? Or Saturday at noon? Or when is that thing due anyway? You don't know? Are you serious? It's due tonight at midnight. Okay? The OpenStack homework is due tonight at midnight. Is it important or not really that important? It's important. Yeah, so do well on it, okay? I'd love for you to make 100% on it. Okay, we started off with this this guy jumping from the Red Bull, and we didn't find out how far he had fallen in this time. So I want to know how far he's fallen in this time. Remember, we really just have two equations. We have our v equals v naught plus at, and then we have this y equals v naught t plus 1/2 at squared. Don't be misled. In the past, I've written this as x instead of y, but it's typical that when you have vertical displacement, you use y. When you have horizontal, you use x. This is the same. I'll just use y for vertical displacement. And I want to know how far he's fallen. So v naught is 0 meters per second. The time was 21 seconds. Plus 1/2 a is minus 10 meters per second squared. Remember that a is equal to negative g, where g has that value of 10. On the test, all the answers that you have will be assuming 10 meters per second squared for g. It just makes the math a little easier. Though on your OpenStacks, they use 9.8. You can still use 10, just know that in the end it'll be a little bit off. Or you can use 9.8. And then 21 squared. I can check my units. The second squared cancel there. Seconds cancel there. Though this goes to 0. And I'm left with negative 5 times 21 squared. What is that? Like 2,000 or something. Yeah, 2205. So we'll call it 200 meters. 2.2 kilometers. So that's how far he's fallen in 21 seconds. Let's look at another problem. May I go down from here, folks? By the way, there is a help session on Tuesday. I think I said 2 o'clock. I know that doesn't work for everybody. Did I say 2 o'clock? Is that right? I sent a message out. Yeah, a help session on Tuesday at 2 o'clock. It's going to be over in Powell in the business school. I got a room over there. But I'll send you that room number. And I'll record it like I do in class here. Although I realized last time I didn't record it because the thing messed up. But I'll do my absolute best to record the help session. So if you can't make it, then you can check it out online. Okay? All right, let's watch this short video clip. This is a video clip from Big Buck Bunny. Big Buck Bunny is about this sort of oversized, really gullible bunny rabbit. He's about 6 foot tall, but he's being picked on by these other animals, these like a flying squirrel and a couple other animals. And in this scene, he is exacting revenge upon the flying squirrel. Have y'all seen Big Buck Bunny? No, it's a cartoon. It's not really a kid cartoon, like it's for adults. But anyway, in this scene, there are two instances of free fall. And in both of them, there are differing sort of takes on the type of information that you have. And I want you to, as we watch this, just pick out the two instances of free fall. That is when something is falling through space. And then we'll address both of those situations sort of from a problem-solving scenario. So let's watch this first. So let's look at these. Do you guys prefer the lights off like this, or do you prefer them on? With them on. Off. Do you prefer them off? We'll try it out. We'll see how y'all do. Okay? So we have two instances of free fall. What were the two instances of free fall? We had one object fall at first, and then another object. What was the first object that fell? It looked like an apple. It's actually a peach. But what's it going to do? I know what you're thinking, that ain't no peach tree, right? Because peach trees are like this tall. That tree is really tall. But it's the Peach Open Movie Project, so it actually was a peach, I'm pretty sure. Anyway, so yeah, we had the apple/peach, and then what else did we have fall? The squirrel. And in both of those, we'll make some estimates about the distances or the times or whatever, but in both of those, there was some information that you could preen from the scenario, and then there's information that you can't preen. And it helps to highlight the different types of free fall problems we have and the different ways that you approach them. So let's take a look at that. Let's first look at the tree. And listen, this is a good practice whenever you're doing problems, that you draw a picture. We have our apple here, or peach or whatever, and it falls down in this direction. We need to set our coordinate system. We're going to take this point to be y equals 0. And so this is going to be our initial y position. That's almost always the case. It really, as far as this class is concerned, always the case. And then the object falls down to the ground, and we want to know a couple of things about it. We know a couple things about it. We know the acceleration. The acceleration is minus 10 meters per second squared. That's not stated, and it won't be stated ever in any problems, but it's always something that you know. When something is in free fall, the acceleration is minus 10. We know that V0 in this case is equal to 0 meters per second. And we know that that y is equal to, well, how tall do you think that tree was? In feet, roughly. 50 feet, maybe? Yeah, maybe about 50 feet. I'm going to say about 20 meters. That's about 60 feet. So it's going to be minus 20 meters. And so now you're asking, gosh, why did you put minus 20? Well, because I'm going from 0, and I'm going in the negative y direction. So down here is going to be negative 20. So this is like my final position. Y is equal to minus 20 meters at this point right here. So I just estimate this. I've estimated the y height, the change in position for this peach or apple or whatever. I don't know the time. And I also don't know what is the final velocity. But I can do this. I can figure out the time, and I can figure out the final velocity. So a couple ways I can do this. Remember my equations. I have v equals v0 plus a times t. And then I also have x, or y rather, equals v0 t plus 1/2 at squared. Now you had a problem on your OpenStax homework assignment. It wasn't exactly like this, but it was similar in that I had two equations and I had two unknowns. And one of the equations had two unknowns in it. This one, because I don't know v, nor do I know t. And one of the equations only had one unknown, like this one, because I only don't know t in this one. So I have one unknown, two unknowns. And you're likely to have a question like this on the test, where you have to solve a system of two equations with two unknowns, but one of the equations will have one unknown. You follow me? Yeah? On the homework in the workbook, those problems in the workbook, there is at least one problem where you have to solve a system of two equations with two unknowns, but both equations have two unknowns. And that's more difficult because you have to solve one equation for a variable and substitute it into the other equation. And y'all can do that, and you certainly should be able to do it. But on the test, I'm not going to make you do that. Y'all clear what I'm saying there? On the test, I will not make you solve a system of two equations with two unknowns in each equation. It's just tedious. It's not that you can't do it. I know that you can, but it's very tedious. So here, what I want to do is I will first solve this equation and find out what t is, and then I'll plug that into the second one, the kinematics for v. So I have minus 20 equals, I'm just going to put 0 here because you know that's 0, plus 1/2 of minus 10 times t squared. And I solve that for t. That's minus 20 divided by minus 5 equals t squared, and so t is equal to 2 seconds. Minus 20 over minus 5 is 4, square root of 4 is 2. So it takes 2 seconds to drop down. Now, I want to find the velocity as well. So I say the velocity is equal to v0 plus at. That's equal to 0 minus 10 meters, or plus rather, minus 10 meters per second squared times 2 seconds. And so I get minus 20 meters per second. Alright, so this tells me my velocity at the bottom here after the object has fallen over 2 seconds. What if I want to know the velocity at 1 second? How would I find the velocity at 1 second? That's right, yeah, if I want to know the velocity at any time whatsoever, like say at 1 second, then I would just say v is equal to v0 plus at. That's 0 plus negative 10 times 1 second, be negative 10 meters per second. That's really the great thing about kinematics, is it's predictive. It can tell me the position of the object at any point in time. And that's really nice when you want to track out the motion of objects. And so I can find out the velocity at the bottom, I can find out the velocity here, I can find out the velocity here. So right about here is probably where you hit that 1 second. You can find the velocity at any point in time. But there are some important points in time where special things happen, like at the bottom, where it comes to the end. Or we'll see some other special cases, like when I throw things up in the air. There are some special times where just particular things happen. All right, listen, let's come back to this. I want to work another free fall problem because it's like what we have on our OpenStax assignment, and then we'll come back to this in just a bit. I want to look at this one. This one is a little long, and so you wouldn't see one on your exam with so many different parts, but you could certainly see a question, a piece of this question on your exam next week. All right, I can take parts of it and put it on your exam. What I have here, this is like the diver question on the OpenStax homework. Y'all know what I'm talking about? The diver jumps off the diving board. I think it was like 8 meters for it to get down to the bottom. Okay. So same problem, just different numbers, different scenario. I have something, I think it's a stone. You throw it up at 20 meters per second. It goes to the top, and then it comes back down. I want to know a few of these few things. I want to know the time needed to reach maximum height, the maximum height, the time required to return back to this point, and then the total time that the stone is in flight. This was the question that you had on OpenStax, by the way. How long is this stone in the air, or this diver? And in that problem, you had to break it into 2 parts, like we'll do here. So some special things here. I know that the velocity at the top is 0, like that duck, Baby Huey. Right? He goes up, and then he stops, and then he comes back down again. Now, of course, it's not exaggerated like that, but it does occur that he goes up and then he comes back down again. So it does stop. Your speed at the top is 0. What is the speed here at this point? How does the speed compare here to what it was over here? Is it bigger, smaller, or the same, the speed? It's the same, right. But what is the sign of the velocity at this point? It's negative. So that's another special point that we need to recognize. And we talked about this last time, but when you return back to the original location, the speed is the same, but just in the opposite direction. So v is equal to negative 20 here. And then it goes and it continues accelerating until it reaches the bottom. So let's look at this first question. What time is needed to reach the maximum height? Listen guys, get really good with this problem because we're going to see it again in chapter 3, but we're going to have it in 2 dimensions. And so it'll be a little bit more complicated, not a lot more complicated, but just a little bit more complicated. But if you get it now, it'll help you on this exam and it'll help you on exam 2. So the time required to reach maximum height, the time required to go from here up to here. What are some things that we know about this? Well, we know that the initial velocity is 20. What are some other things that we know? Just take a moment and write down the things that we know about the motion as it occurs from this point up to this point. Like, what is the final velocity? What is the acceleration? Do we know the height? Do we know the time? What do we know about this scenario? Just write down what you know and write down what you don't know. Okay, so I'll give you a second. I know the acceleration. I always know the acceleration, right? Right? Yes, it's minus 10 meters per second squared. I also know that the velocity at the top, excuse me, is equal to 0 meters per second. It's one of those special points. I don't know the time. I want to know the time. And I don't know the y height. Although for part B, in fact, we'll just call this A plus B right here. So we'll go and do part B as well. Because I want to know what is the position at that topmost point. So to find the time, I always like to write my equations up here at the top of my page. V equals V naught plus AT. It just helps remind me what I know and what I don't know and how these variables are related to one another. Y. Well, let's see. So if I want to know T, I know V naught, I know A, and I know V. So I know V, I know V naught, and I know A. So I can solve that for T. I just have one unknown. So I say T equals V minus V naught divided by A. What I did there is I subtracted V naught from both sides, so I got rid of that, and then I divided through by A. V minus V naught over A. And that gives me 0 minus 20. Be very careful with your units divided by 10, not your units, your signs. Be careful with your units too. But be careful with your signs because often on the exam you might have a negative answer and you might have the same answer that's positive. Or often, you need to know this about my exams, is that you don't have the right answer and then a bunch of random wrong answers. That you have the right answer and then you have other answers that are common mistakes. You need to know that about my exam, that if you give an answer, it's not necessarily right. Because I know what mistakes you make, and I'll work it that way and get an answer so that you see that answer. So be very careful. Lots and lots of practice will help you on that. Lots and lots of practice. So anyway, point of that is be careful with your signs, because students often make mistakes with signs. Minus 20 over minus 10 is 2 seconds. Time comes out positive. That's a good thing because time should always be positive just physically. If it came out negative, you know that you made a mistake somewhere. So that's the first part. And then if I want to know the height, then I go to this because now I know everything there. In fact, y is equal to 1/2, is equal to v naught times t plus 1/2 at squared. That is going to be 20 times 2 plus 1/2 of negative 10 times 2 squared. And that gives me 40 minus 20. Is that right? 5 times 40 times 20. So it gives me 20 meters. It comes out positive, which is good. It should come out positive the way we set up our coordinate system. So I can sort of have these little checks along the way. If it came out negative, you need to go back and say, oh, I made a mistake somewhere. But it came out positive because, well, this is how I set up my coordinate system. It starts there, and then it goes up here to positive 20 meters. All right, so it takes 2 seconds to reach maximum height. It takes 20 meters. What is the time required for it to go up and then back down again? You throw the thing up, and then it comes back down. How long does that take? Think for just a moment. I know the time that it takes to go up, but how long does it take for the total duration of the trip to go up and then come back down again? What do you think? 4 seconds is right. Because it takes 2 seconds to go up and 2 seconds to come down. So the total time for this thing, which is part C, I think, is 4 seconds. Be careful on that OpenStax question that you double that time. Like you get the time to go up, and then you double it, and so that gives you the time to come back to the original position after this guy jumps off the diving board and then comes back down again. So the total time for the stone in flight, or excuse me, to return back to y equals 0 is 4 seconds. That's 2 seconds, which is the time up, times 2 to get it to come back down again. And now part D, which is really what the OpenStax question was asking, is what is the total time in flight? I know it's going to be 4 seconds plus some other time. We'll call that T2. So I want to find out what is the time for T2. I'm going to draw another little picture. I have this object, it's going down, and it drops, was it 50 meters? Yeah, 50 meters. All right, it goes from y equals 0 to y equal negative 50 because, you know, it's in the negative direction. I know that it has a velocity, which I'm going to call this v0. I've switched reference frames. I've switched where my coordinate system is. My new v0 is going to be minus 20 meters per second. That's just the opposite in direction of the original velocity, right? It goes up, comes back down, and when it comes back to where it was, it now has a speed that's in the same magnitude but opposite direction. Okay, y'all hang with me. I know this is tedious, but these are good problems to work through. You're not going to have this whole problem for the test, but any little piece of it you certainly will have on the test. Okay, so now I want to know the time. I'll write down what I know and don't know. Y is negative 50. V0 is negative 20. A is equal to negative 10. I don't know what V is. I don't know what T is. I'm going to call this T2 because it differentiates from the first T that we found. All right, write my equations up here. And then I need to find T. I'm not going to do this here because you have to use what to find T? The quadratic formula. So it gets a little tedious. You're not going to have to use the quadratic formula on the test next week, but you will have to use it on your OpenStax. So you want to take this, because I know Y, I know V0, and I know A, and you're going to solve this for T. All right, solve it for T. All right, when you get that, to find the total time, you say 4 seconds plus whatever T2 is. And that'll give you the answer. I forget what the answer is. But if you're unclear on how to use the quadratic for the OpenStax, come see me or Google it. I don't really care if you, I care if you can use a quadratic, but I expect that you can use it. If you want to use an online calculator for the quadratic, that's fine too. It's not that hard. Y'all can do it. I know that you can, but I'm not going to test you on it. Okay? So that's just like the OpenStax homework question about the diver. He goes up, he comes back down, and he wants to know this total time. It's really 3 parts that you're breaking it into. The time to go up to the top, then you double that time to get the time to come back down again, and then you do the second part to add in the total time. Any one of these parts we could have on the test as a separate question. All right, let's go back to the big buck bunny one. Oh, actually here. So if you want to know V at 5 seconds or T at 5 seconds, I'll do it off here to the side. If you want to know V at 5 seconds, all you say is V equals V naught plus AT. You put in your original value, that's 20 meters per second, minus 10 meters per second squared, times 5, that's your seconds. So that's 20 minus 50, which is negative 30. So does that tell you that at 5 seconds the object is going up or coming down? Where is it? Going up or coming down? It's coming down because it's negative. Is it going to be above or below? Where will this object be at 5 seconds? Will it be up here or below? Above or below? Sorry, I didn't know. What was it? Below. All right. I know that. I mean, I know because I know that here it's at 4 seconds. But I also know because here it's at minus 20 meters per second. And so now it's going minus 30 meters per second, so it's sped up. So it's come here and then it's increased speed to 30 meters per second in the negative direction. Oh, there's somebody else. Okay. So, and then if I want to know y, like, you know, the displacement y, then I say v naught t plus 1/2 at squared. And I can actually find out the position, you know, that the position is right there, whatever it is. Okay, people? Yeah? Are y'all a little nervous about the exam? I want you to be a little bit nervous about the exam. Okay, you need to be a little bit nervous about the exam because I want you to come into this exam knowing it really well, and I want you to come out of it with a really good grade because it'll help as the semester goes along. This probably isn't our hardest exam, but the next exam will probably be the hardest. But you want to go into it with a good grade, okay? You know how you make a good grade? You practice, 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 practice. Work through those old exams. You have a week to do so. Work through all the old exams. You have some in the back of your workbook. Go through the concept test. I will pull questions sometimes from the concept test. As you go through the old exams, you'll see this. And then also, make sure you look at your OpenStax questions. I will pull questions from that as well. They're not going to be the off-the-wall questions, like the money. That was kind of difficult and tedious. But you will have questions. I will pull them. They'll be almost verbatim. I'll change the numbers, so don't bother memorizing the numbers. But they'll be almost verbatim from there. You'll be able to recognize them, I'm pretty sure. Okay, let's do that other question for Big Buck Bunny. There's an extra page there if you need it. So we had the apple fall, or the peach or whatever it was. Oh. And then we also had the flying squirrel fall. So we had this flying squirrel. And let's see, in this one, in the previous clip, it was in slow motion, so you didn't know the time when that apple fell from the tree. But in this case, you can find the time. And so I've calculated the time, or I've measured the time from the clip. The time from the clip is that t is equal to 4 seconds. A is equal to minus 10. Just writing down what I know. And v naught is equal to 0. And I want to know what is the height, y, and I want to know what is the velocity at the bottom. Now, this time is twice the time that we had in the previous part, right? Because in the previous one, we found that the time that he was falling was this 2 seconds. So I want you to think now, if that was 2 seconds, what's going to happen in 4 seconds? Now, in the previous problem, the y was equal to, what was it? 20 meters. That was the height that he fell. I want you to tell me. Let's do it as a quicker question, actually. You know, we're not going to work it out. Don't try to work out the problem. I want you to think. If I double the time, how does the distance change? Maybe it's 10 meters. Maybe it's less. Maybe it's the same, 20 meters. Maybe it's 40 meters. Or maybe it's 80 meters. Let's try this. If I double the time, that is, in 2 seconds, I fall 20 meters, how far will I fall in 4 seconds? Will I fall 10 meters, 20 meters, 40 meters, or 80 meters? If I double the time, what happens to my y displacement? All right, feel free to ask your neighbor. I'm going to give you about 5 more seconds. What do y'all think the answer is? The answer is D. Okay, let me show you why. We had a question like this, and this is where it's going to come back to see you. Y is equal to 1/2 at squared. Remember that question we had in chapter 1? Y is equal to ax squared. You double x, what happens to y? That business. This is a quadratic equation, a quadratic formula. And so if I double t, what happens to y? Well, if I make a 2 right here, I double t, because it's squared, I get 4 times the y distance. And we can see that if we calculate it, we see y is equal to 1/2 at squared. That's 1/2 of -10 times t, which is 4 seconds. That's squared. That's equal to 80 meters, or -80, because we're going, you know, below the origin. All right, let's try another question. If the velocity in 2 seconds, the velocity was, what was it, 10 meters per second, or the speed was 10 meters per second, what is the velocity at t equal 4 seconds? Is it 5, 10, 20, or 40? Okay, we'll stop at 45, 45. Okay, so I understand why you put this based on what we had in the last problem, right? Because you said, well, in the last problem, it multiplied it times 4. If I doubled my time, I multiplied the result by 4. But in this case, it's not a quadratic relationship. It's a linear relationship. So I have V is equal to A times T. So if I double T, what happens to V? What's going to happen to V if I double T? What's going to happen? It gets doubled as well. Right? So whereas it was 10, now it's going to be 20. Let me step back and show you. So in the previous problem, and in this problem too, at t equals 2 seconds, the velocity was 10 meters per second. Well, what happens if I double my time and I go to t equals 4 seconds? What's going to be my velocity now? Well, since I have this linear relationship, v is equal to v naught plus a times t. V naught is 0, it just goes away. So I just have v equals a times t. If I double my time, I double my speed. And we can calculate that. We can say, well, v is equal to at. That's minus 10 meters per second squared. And then I put in my time, which is 4 seconds. Oh, I'm sorry, it was... No, did I get this wrong? Oh. Did I make a mistake? I did? Why didn't y'all tell me? I'm confused now, too. D is the right answer. Good job. What is the question, then? Yeah, D should be the right answer. Oh, I'm sorry. This was actually 20 meters per second up here. That was my mistake. I'm sorry. I'll give you a joke. That's not really a joke-worthy question because you only got 85%, but I'll give you a joke. How about that? You ready? Why does the gingerbread man never go to the beach? He has crummy legs. Get it? Y'all got it? You didn't get it. Okay. What's the funny joke? Alright, we're not done. I don't think. Okay, yeah, so it should be minus 40. I'm sorry about that. But it still is true, though, that it's a linear relationship. If I double my time, I double my speed. It was 20, now it should be 40. Alright, while we have a couple minutes, I know you are eager to go, but let's just do a couple questions in the back. Let's do number 12, okay? Number 12 here. You throw a ball up with an initial speed of 30 meters per second. How long does it take for the ball to return to your hand? This is just like that problem we did with the stone we threw up, but it's just one small part of it. We're running short on time. I'm going to work it with you, okay? All right. What is the time to go up to the top? It takes 3 seconds to get up to the top, and then to come back down to your hand is another 3 seconds. So the total then is what? 6 seconds. Make sure you put in D, okay? And have a great day. I'll see you Friday. We will have a little bit of extras up next test, okay? We'll do that on Friday.